In this microcontroller lab video, we are now going to look at how to control the LED fading with the pulse width modulation. So pulse width modulation is a technique in which we control the width of a signal. And we will now build a microcontroller circuit, and by using the microcontroller PWM, we should be able to control the brightness of the LED such as the fading. Now you can go and import your Arduino Uno, and we can connect a resistor, and we can connect the LED. And we can do the connection as follow. We can connect to pin 9, and we go to the terminal, and we can now insert the ground, and we will now be able to give instruction to this microcontroller to control the brightness of this LED. And now our circuit is complete. We are now going to program this microcontroller so it can control the brightness of this LED. And we can configure the resistor having 220 ohms. Let us open our integrated development environment. So this is our Arduino IDE, and we are going to write the instruction so that this microcontroller can execute. And let me put it in side-by-side view so we all can be able to see the microcontroller pins, and we can program respectively. Now from this view, we now be able to specify the pins of this microcontroller, and we can now be able to give the pin, let's say LED pin, and it is connected to pin 9, and we can give the value int, and we can say the brightness, which is the variable, and should begin with 0, and we can say integer and fade amount, and we want the brightness to fade with the amount of 5. Now this is done. We already initialize all the variables that is needed for this particular Arduino to operate, and now under the void setup, we now have to declare pin mode, which is the LED pin, to be the output pin. That means it will only give out data. And now we can go to the continuous loop, and now we will give a command such as analog write. And now we are writing analog values to the LED pin, which is the pin 9, and it will compare with the brightness. And in this case, we can say we set the brightness from 0 to 255. That means in the range of 8 bit. And now we can say the brightness is plus or minus the fade amount. And what does this plus and equals mean? We know that the brightness is a variable and the fade amount is also a variable, and the brightness is begin from 0 and all the way to the fade amount, which is positive 5. So this plus and minus is an operator in the Arduino code that is used to perform addition on a variable with another constant or variable. And we can see that this brightness is headed to the fade amount, because fade amount is a variable having a constant, and we are heading the brightness to this fade amount. And now we can be able to give a condition, and let's say if the brightness is less than or equal to 0, and we are performing an operator that will compare the brightness when it is greater than or equal to 255. And then we can say the fade amount is equals to minus the fade amount. And in this case, we can say that we reverse the direction of the fading, and we can now simply add a small delay of 30 milliseconds, and this is used to, we can say, smooth the fading effect. Now I will explain to you the code under the void loop. This is the most important code that will control how the LED will behave. And the first function is the analog write. Now this analog write is telling the microcontroller to write the analog signal to the LED pin, which is the pin 9, and not any analog signal but the pulse width modulation signal. And this pulse width modulation signal will be set with a brightness of 0 to 255, which is in terms of the 8-bit. And when we say when the brightness is 0, the LED will be switched off. And by increasing the value towards 255, we are gradually increasing the LED. And when the value of the brightness is 255, now the LED will be fully light up. And in that case, if we are to decrease the value from 255 to 0, we are now decreasing the value from brightest to bright and all the way to the LED being switched off when the brightness is equals to 0. In order to increase this type of brightness for the LED, we initially have a variable such as the brightness, which is the 0. And by using the operator plus equals the fade amount, we are now adding the value of the brightness with the fade amount. Initially it is 0, and 0 plus the fade amount, which is constant 5. Now the brightness will store the value, which is 5, and it will execute the next following line of code where if the brightness is less than equal to 0, or if the brightness is greater than or equal to 0, where we have the brightness value which is 5. So this is in between. Therefore, this statement will be false. So after a delay of 30 seconds, it will go back the loop and it will start to execute. The second execution where brightness is equals to 5. So 5 plus the 5 is equals to 10. Now after this, the variable brightness will have a value of 10, and it will come to the code and it will start to compare. And we all know that 10 is in between 0 and 255, so this will be false, and after a delay of 30 seconds it will go again. Until several count, we can be able to see that the value of the brightness will now be greater than the 255 after multiple adding. And this condition, if the brightness is less than equal to 2 or brightness greater than or equal to 255, this condition, brightness is greater than or equal to 255, will be true. Therefore, the fade amount will be equals to the minus of the fade amount, because the brightness is 255. Now we will start to minus 5, and we can be able to see that the value will now decrease. Previously, the value of the brightness increased from 0 to 5 to 10 and all the way to 255, and when it is greater to 255, then this condition will become true where the brightness is greater than 255. Now it will start to fade the amount by minus 5. So in this case, the brightness will decrease all the way to 0. and when it is 0, and it will start to execute the code again. So we can see that the brightness will increase to 255 and then will be decreased to 0, then increase to 255, and it will be continuous under the continuous loop. Now, after that, you can be able to compile. Once it is done, you can compile and you can export the compiled binary. And once it is exported into this microcontroller, we can now be able to simulate. So we can click the run. So we can see start from 0 to 255, then 255 to 0, then 0 to 255. So we can be able to compare with the code such that when the value increase from 0 to 255, the LED will be from off to on, and then it will gradually decrease. Once the LED has reached its maximum value, it will decrease back to 0, and then from 0 it will increase back to 255, and the loop is continuous. So I believe you should be able to appreciate that by understanding a instruction code like this, we can now be able to control a microcontroller to perform certain tasks like fading the LED and controlling the LED to operate in such a way that we want it to behave. So this is the important thing about writing a instruction code and store it in the program memory of the microcontroller, and then this microcontroller can perform the task based upon the instruction code. So this is the end of our video. I believe you have learned something about this video.
Thank you for watching our video. Kindly subscribe to our channel and share this video with your friends so they can also be able to learn.